Hi guys, if you have questions, email me or write a comment.
Well, today I'm going to talk about optimization problems. Let's say that I'm asking you something. I need to fence a field of 1,600 meters squared, and I'm asking you to give me suggestions such that I will have a minimum amount of fence. How do you do that? As you know, fence needs money, and the amount of fence that I'm gonna use will cost me money. So I need to know how much exactly would I pay and what is the best dimensions, what are the best dimensions that I can use to fence my required area, which is in this case 1,600 meters squared. You may come up with some suggestions like, let's say, okay, let's say you may tell me, why don't you make it as this one or this one or this one. I may have many suggestions actually, and let's say that you told me, why don't you use 80 meters by 20 meters? And someone else may tell me, why don't you say or use 40 meters by 40 meters? What about 160 meters by 10 meters? All of these will give me 1,600 meters squared. But what about the amount of fence that you want me to buy? In this case, the fence, of course, here will be 100 times 2, which is 200 meters. In this case, it's 80 times 2, so I'm talking about 160 meters. In this case, I'm talking about 160 plus 10, that's 170 times 2, 340 meters. So as you see here, suggestions, all of the suggestions will give me the same area, but will cost me different amount of money. You may come up with different suggestions with different amount of money. So I need the exact and the minimum amount of money that can be paid. What's the minimum fence that I can be using here? Well, we're not going to depend on luck. As you see, we're talking about minimum, minimum, minimum. And this is one of the extreme values that we studied in the first derivative. So we can use actually first derivative test to decide what is the best value of x here that will give me the minimum amount of fence. How would that happen? I'm going to depend on the word that I'm using here, minimum amount of fence. So I'm talking about minimum fence. Fence of what? Fence of a rectangular area. So I should have a drawing here about my area. Let's say, since I don't know dimensions, I'll give them names, x and y. And I need the minimum fence, so I'm talking about the perimeter of this rectangle. So what's the perimeter? The perimeter is equal to 2x plus 2y. And is that enough? 2x plus 2y. So according to first derivative, I need to have only one variable. In this case, I have two variables. I have x and I have y, which means I need an extra information to make it depend on one variable. From where would I get that? I will get it from here. We have 1,600 meters squared. So the area of the field that I'm talking about is given. So I'm going to call that a secondary equation, because that will help me. So the area here is given, which is x times y. So 1,600 is equal to x times y. Now, since I have an equation that has only x and y, and here I need to replace one of them in terms of the other, so it's simple to choose any of them since the equation is the same here. So let's say I want to solve for y, so y will be equal to 1,600 over x. Now I can replace the y here by 1600 over x, which means I will be having a perimeter equal 2x plus 2 times 1600 over x. By simplifying this, the perimeter will be equal to 2x plus 3200 over x. Now we have a relation between the perimeter and x, and if I can derive this now simply. Remember, why do I need to derive this? We are talking about minimum, so I need a value of x that will make the fence minimum, or in other words, the perimeter minimum. And minimum values and maximum values can be found by using first derivative test. So let's derive this. P prime will be equal to 2, and when you derive this, you will get negative 3200 over x squared. And to check for maximum minimum, you need the critical values, and in this case I'm gonna depend on the zeros of the derivative only, since the values that are undefined doesn't satisfy in such real world problem like this. So when you solve this equation, what will you get? You will get 2x squared equal 3200. So x squared is equal to 1600, which means x equal either plus or minus 40. And since I'm talking about the fence can never be negative, so I'm talking about the 40. Now let's check. Would that really give me a minimum value? To check minimum maximum, as we used to do before, we need to check the sign of the derivative on the number line. So here I'm gonna check p prime. Let's choose a value less than 40, and of course in this case should be more than 0. We cannot choose values less than 0. The length cannot be negative, so I'm gonna choose 1. I'm gonna keep the 0 open here so as we cannot use it. So let's say 1, 2 minus 3200 over 1, that's 2 minus a very small negative value, so it's a negative. Let's say 50, 3200 over 2500, that's for sure 1 point something, so 2 minus smaller value, that's a positive value. So we have here decreasing, increasing. So yes, this value of x, the 40, will give us a minimum value. So if x is 40, what about y? So what is y? Y will be equal to, let's go to our secondary equation. It's 1600 over x. So 1600 over x, so 1600 over 40, which is again 40, or in other words, my field should be a square field, not a rectangular field. It's a 40 by 40, and that will cost me 160 meters of fence. Well, this is how we use calculus to help us in our life. And this is one of the best topics to talk about the applications of calculus in our real life. I hope that you understand what is meant by optimization problem and how it should be used. Just to remind you, what should you do if you want to solve it? The first thing you should do is to recognize the sentence that talks about minimum or maximum. Then you need to draw. Then you need to write a relation. After the relation, you have to look for a secondary equation. And then you replace from that secondary equation. You need the secondary equation to replace it in the relation that you found. Then you need to derive. After you derive, you need to check the sign to check for minimum maximum. That's it, and I hope that you understand. Good luck. Well, let's talk about another simple example just to get used to the steps. Let's say I'm looking for two positive numbers such that their product is maximum and their sum is 20. Let's try to apply the steps that I've said before. The first thing is the sentence. We have a maximum product, and then we need to sketch. In this case, there is no sketching, so let's say the first number is x, second number is y. And instead of drawing and writing names of sites and things like that. Maximum product, so we can write the relation, a function equals x times y. Now we need a secondary equation. What is our secondary equation in this case? What do we have? Well, we have their sum as 20, so I can say x plus y equals 20. I can replace any of them. Let's do it in the opposite way here. Let's do replacing x since we did y in the previous one. Actually, that depends on the shape of the function. In this example and the previous one, replacing x or y doesn't make a difference. But in some cases, let's say we have a power or things like that, we look for the simpler one to be replaced. So let's say x equals 20 minus y. What's going to happen to my function now? It can be written as f equals 20 minus y times y, so it's 20y minus y squared. We have our function ready. Now we can use the first derivative test to check for maximum and minimum, and here we are looking for maximum. So let's see, how do we get our maximum? Derive this, 20 minus 2y, make it equal 0 to find the critical value, so y will be equal to 10. Now check that on the number line. Again, I'm talking about positive, so we will start from 0. 0 is opened. Let's check the sign of the first derivative. So choose a number less than 10, let's say 1. 20 minus 2, that's positive. Greater than 10, let's say 11. 20 minus 22, that's negative. So increase, decrease, what do we have here? We have a maximum. So y equals 10 will give us a maximum value. What's the other number from here? X equals 20 minus 10, which means x equals 10. So the two numbers that their sum is 20 and their product is maximum will be 10 and 10, such that the product is 100. Well, this is just to show you how to apply the steps. Of course, it's not the same all the time, so don't think that x and y will always be the same. It's only a coincidence in these two cases. Good luck.
Remember to like, share, and subscribe, and write your questions via email or comments.